On this review, we're going to look at solving equations, and these are going to be quadratic equations using the square root property. Now, the idea about using the square root property is this. Whenever you have some expression squared equal a number, okay, so if you have a number on the other side, to get that expression by itself, you want to get rid of that squaring. So the opposite of squaring is to square root. So you're going to see that you're going to be taking the square root of both sides. So look something like this. So let's say we had x squared equal, let's say 9. So you can look at this equation and determine right away what the solution is. So what number squared or what number times itself is 9? Well, you could say x equal 3. That's an easy one to figure out, right? Because 3 times 3 is 9. But there's another one also. What about negative 3? Isn't negative 3 times itself 9 as well? And so, in this case, the solutions would be, you could write it as a plus or minus 3, a positive 3 or a negative 3. So the idea is this. It's not going to be always this easy. So you got to think about, well, if I'm squaring x and I want to get x by itself, right now I'm squaring it. The opposite of squaring is to square root. So I'm going to take the square root of both sides. But you just saw that in this particular case, you have a positive 3 and a negative 3 as your answers. So you got to say plus or minus. So whenever you take the square root of both sides of an equation, you can do that plus or minus symbol. Okay? So that's the idea. So let's look at the first one. So number 1, we have 3x minus 2 squared equal 64. Now always remember, before you take the square root of both sides, you want to make sure that what's being squared is by itself on one side. And in this case, it is. This expression is being squared and it's by itself. So once you get it by itself, then you can take the square root of both sides. So to get rid of that squaring, the opposite of squaring, see right now I'm squaring this binomial, right? I'm squaring this expression. The opposite of squaring is to square root because you want to get this expression by itself. So I need to get rid of that squaring symbol. So let me go ahead and rewrite this over. So it's going to look like this. So you can take the square root of both sides. But remember, just from this example we just saw, you're going to have to use plus or minus. You need that plus or minus because the square and the square don't do each other. So that means that 3x minus 2 equals a positive 8. Square root of 64 is 8, or a negative 8. Now, since the square root disappeared, so to speak, meaning that 64 was a perfect square, you end up with a rational number. See, this is a rational number. So 8 and negative 8 is a rational number. So you can end up with rational solutions. So in that case, let's just split them apart to actually figure out what they are. So 3x minus 2 equals a positive 8, and 3x minus 2 equals a negative 8. And then you can solve each of those linear equations. So notice I went from a quadratic, see this is quadratic, because if you follow this out, you get 3x times 3x is 9x squared. So you have that x squared term. So you have this quadratic equation, and you went from a quadratic equation to 2 linear equations. So let's solve each linear equation. So over here, I get 3x equal 10, adding 2 to both sides. Divide both sides by 3. I get x to be 10 thirds. Okay? Over here, I add 2 to both sides. So I get 3x equal a negative 8, and 2 is a negative 6. Divide both sides by 3. I get x to be a negative 2. So those are your solutions. So the solutions to the original equation is 10 thirds and negative 2. All right, so that's number 1. So that's solving a quadratic equation using the square root property. Now remember, in order to use the square root property, it's got to look like this. You have to have some expression squared equal a number. It's got to have that expression. All right, number 2. So let's suppose in number 2 we have this problem. We have 5x minus 6 squared equals 7. So it has that same form as the previous one, doesn't it? 3x minus 2 squared equals 64. So you have an expression squared equal a number. The problem, or the difference rather, between number 1 and number 2 is that when I take the square root of 64, 64 is a perfect square. You no longer see a square root. So that becomes a rational number. Here, to get rid of that squaring, I got a square root, just like I did in the previous problem. So you can take the square root of both sides, plus or minus. Notice this time, though, that 7 is not a perfect square. So I cannot simplify the square root of 7. So what I end up with, well, let me go ahead and rewrite this over. So the square and the square root into each other. So what I end up with is 5x minus 7 equals plus or minus the square root of 7. And remember, the square root of 7 is an irrational number. So you're going to end up with irrational solutions. In the previous problem, I ended up with rational solutions. So in that case, you could actually tell me what those two rational numbers are. So you break it apart like this to get those. Here, though, you're going to end up with irrational solutions. So there are multiple ways of writing it. And you need to know those multiple ways of writing it just in case the answers are multiple choice, and so you know which ones are equivalent. Okay? So here's one way to write the answer. So since this is irrational, I'm going to leave it as plus or minus. And remember, you're trying to get x by itself. So I have this linear equation. It just so happens to have an irrational number in it. So this is going to be an irrational solution. So I'm going to add 6 to both sides, just like this. And remember, that's one approach of writing the answer, of the solution. So I get 5x equal 6 plus or minus the square root of 7, just like that. And then you get x by itself, you divide both sides by 5, like that, and you get x to be 6 plus or minus square root of 7 divided by 5. And that's it. You can't simplify anything else. So you can write it, you can write the solutions in compact form like this, plus or minus. You could also write those solutions separate. See, there are two solutions. There are two solutions. This says there are two solutions. One is 6 plus the square root of 7 divided by 5, and the other is 6 minus the square root of 7 divided by 5. This is the same thing as this. Okay? Now, here's what someone else would have done to make it look just like this. Remember how we split it apart like this? You could have done that with this. I just went ahead and left it like this because this was an irrational number. Here, if it's rational, you do have to split it apart to tell me what those rational numbers are, the rational solutions are. So you could have done that here. You could have said 5x minus 6 equals square root of 7. 5x minus 6 equals negative square root of 7, right? And then notice when you do it this way, though, you're going to get this part. So watch. I'm going to add 6 to both sides. So I get 5x equals 6 plus the square root of 7, right? This right here is this. Divide both sides by 5. I get x to be 6 plus the square root of 7 divided by 5, which is this right here. Over here, I add 6 to both sides. And so 6 and negative 6 is 0. I get 5x equal 6 minus the square root of 7. Divide both sides by 5. I get x equal 6 minus the square root of 7 divided by 5. Okay? So those are your solutions written separately, which is what we had here. But let me remind you also, you see what I have here? Where I have these two terms divided by one term, a monomial. You could also say this, 6 divided by 5 plus the square root of 7 divided by 5. So you could write this, where I have that one fraction, you can write it as two separate fractions, the sum of two fractions. Same thing here. You could say 6 fifths minus square root of 7 fifths. So these are all different ways of writing the answer. You could have done that here. You could have done this. You could have said x equal, where we said x equals 6 plus or minus square root of 7 divided by 5. You could have said 6 fifths plus or minus square root of 7 fifths. Same thing. Those are all equivalent. Those are all equivalent solutions. Okay? All right, so that was number 2. So notice it's important you understand the difference between rational solutions and irrational solutions. See how your answer had that square root in it? So the square root of 7 is an irrational number. So you have irrational solutions. And number 3. So in number 3, let's suppose we had this for number 3. We had 2 minus 5x squared minus 2 equals 26. Oops, 26. That's a 26. Okay, now remember, before you can take the square root of both sides, remember you got to get that expression squared on one side. I don't have this by itself. See how you're subtracting 2, so you got to get rid of that subtracting 2 first. So we're going to add 2 to both sides first. And then what I have next is 2 minus 5x squared equal, and then 26 plus 2 is 28. And now notice that I have a expression squared, so I want to get that expression by itself, so I need to get rid of that squaring. And the opposite of squaring is just square root. And remember, when you take the square root of both sides, you got to do that plus or minus. And so the square and the square root undo each other, so you get 2 minus 5x on this side equal, and then remember you have the square root of 28, right? You can simplify the square root of 28. Now 20 is not a perfect square, so this is going to be an irrational number, but you can still simplify it. The largest perfect square that goes into 28 is 4, so it becomes the square root of 4 times the square root of 7, and the square root of 4 is 2, so this is 2 square root of 7. So this right here becomes plus or minus 2 square root of 7. Notice you have that square root still, so that's irrational. So you're going to end up with the irrational solution. So you're going to do it just like you did these right here. So you have multiple ways of writing your solutions. So let's go ahead and get x by itself. So let's go ahead and subtract 2 from both sides. So 2 minus 2 is 0. So I get negative 5x equals a negative 2 plus or minus 2 square root of 7. Okay? And then divide both sides by negative 5. Divide both sides by negative 5, and you get negative 5 divided by negative 5 is 1. 1 times x is x, equal negative 2 plus or minus square root of 7 divided by negative 5. Now, you can leave your answer like this. There's nothing wrong with that. It's correct that those are your two solutions. Just keep in mind there are two solutions, right? Plus or minus. Negative 2, there are two solutions. Or you could say negative 2 plus the square root of 7 divided by negative 5. The other one is negative 2 minus square root of 7 divided by negative 5. Keep in mind, though, if this were a multiple choice item, you would probably not see a negative 5 in the denominator. So let's talk about some other equivalent solutions. Okay, so listen carefully. So y'all remember a negative divided by negative is a positive, isn't it? Okay, so I want to show you something. So I'm going to rewrite this as negative 2 divided by negative 5, right? Plus or minus square root of 7 divided by negative 5, right? So this divided by negative 5 plus or minus this divided by negative 5. That's what you see here. Remember, though, a negative divided by negative is a positive, so this is really 2/5. Plus, now be careful. A positive divided by negative, see this right here? Positive divided by negative is a negative. See that negative? A negative divided by negative is a positive. So a plus or minus divided by negative is still plus or minus. So this is plus or minus square root of 7 divided by 5. So there's another way you can write the answer. You could put this in compact form and say this, 2 plus or minus square root of 7 divided by 5. And so here's another way of writing the answer. So when most of you would have said negative 5 here, on a multiple choice item, it would have probably been a positive 5. So you just got to recognize that this and this are equivalent. This and this are equivalent. A negative 2 divided by negative 5 is a positive 2 divided by 5. A plus or minus square root of 7 divided by negative 5 is a plus or minus square root of 7 divided by positive 5. Those are all equivalent. All right, so that's number 3. Let's look at number 4. In number 4, we have, forgot one more thing. I'm sorry. See this right here? This was 2 square root of 7, right? What did I forget? I forgot the 2 right here. So I just got to go back and put the 2's in there. So don't forget to put the 2's just like this. All right, so 2 square root of 7. When I wrote it, I forgot to put the 2. So 2 square root of 7, 2 square root of 7, and so on. Okay? All right. Number 4. In number 4, we have this for number 4. We have x minus 5 squared equals, let's say, a negative 9. All right, now listen carefully. One of the things you learned in one of the lessons was the idea of imaginary numbers. All right, imaginary numbers. So if you take the square root of a negative 1, remember the square root of a negative 1 is not a real number. That's not a real number. No number times itself is a negative 1. No real number times itself is a negative 1. So this becomes, in terms of our discussion, an imaginary number. We define the square root of a negative 1 as the imaginary unit I. So that's defined, square root of negative 1 is defined to be I. And then if I square both sides, let me just remind you, if I square both sides, we also define I squared to be negative 1. Okay? But for our purpose, all you have to know is that the square root of a negative 1 is defined to be I. So we have this imaginary unit. So sometimes they'll refer to a solution that has I in it as a complex solution, but it's really a complex imaginary solution because real numbers are complex numbers as well. But when we talk about just a number with an I in it, we actually say complex imaginary solutions or complex imaginary numbers. Okay? All right, so let's talk about this. We have the expression squared all by itself. So I'm trying to get x by itself. Now be a little bit careful. This is negative on this side. It's not positive. So we have to be careful. We have to use the fact that we're dealing with imaginary numbers here. Okay, all I did was rewrite it over, and I'm going to square both sides, just like that. Notice the negative 9's under the square root symbol. Don't forget that plus or minus though. The square and the square root undo each other. So you get x minus 5 equals plus or minus. Now, here's where you got to think about the square root of negative 9. The square root of negative 9 is defined to be the square root of a negative 1 times the square root of 9. Negative 1 times 9 is negative 9. We just saw that the square root of a negative 1 is defined to be the imaginary unit I, and the square root of 9 is 3. So the square root of negative 9 is just 3i. We tend to put the I at the end of our expression. So this right here is plus or minus 3i. So I have my solutions are complex imaginary solutions. So you have that imaginary number, that I, imaginary, I for imaginary. And all I do is add 5 to both sides. Leave it as plus or minus 3i. Add 5 to both sides, and so I get x equals 5 plus or minus 3i. Now those are not like terms, so you can't say 8i plus or minus 8i. Those are not like terms. They would be like terms if both of them had I in it. Okay? All right. So that's it. That's your answer. Those are your solutions. Now, if you want to split it apart, just like we did before, you would say x equal 5 plus 3i, and then x equal 5 minus 3i. So that's another way of writing your solutions. You have two solutions. This is more in a compact form than this is. Here we're just writing them separately. Okay? All right, so that was number 4. Let's get number 5. So number 5, we have x minus 3 squared equal a negative 32. Notice that negative number on that side. So what's being squared is already by itself. So the next step to get rid of that squaring is to take the square root of both sides. So let's go ahead and do that. So I'm going to do the square root. Notice negative 32 is under the square root symbol. Don't forget your plus or minus. Then the square and the square root undo each other. So you get x minus 3 equal plus or minus. Now let's talk about the square root of a negative 32. I can rewrite the square root of a negative 32 as the square root of a negative 1 times the square root of 32. And we know that the square root of a negative 1 is defined to be I. But just if you remember the previous one, the square root of 9 is just 3, right? Because 9 is a perfect square. Well, 32 is not a perfect square, but you can simplify the square root of 32 because there is a largest perfect square that goes into 32. There is a perfect square. There are several, but let's use the largest. The largest is 16. So this is the square root of 16 times the square root of 2. And the square root of 16 is 4. So I get I times 4 square root of 2. And I'm going to go ahead and put the I between the 4 and the square root of 2. So I'm going to write this as 4I square root of 2. So that goes here, 4I square root of 2. So just as before, I have, since I have I in my solutions, I have complex imaginary solutions. I'm going to have complex imaginary solutions. And we're going to write it just like we did this one. So you're going to just add 3 to both sides. And you get x equal 3 plus or minus 4I square root of 2. Notice though, you still have two solutions, right? Your two solutions are 3 plus 4I square root of 2, comma, 3 minus 4I square root of 2. Okay, so those are two different ways of writing your solutions for that one. But notice you have that I in there, so you have that complex imaginary solutions. All right, let's look at number 5. In number 5, we have this for number 5, number 6 rather. Number 6, we have 2x plus 1 squared plus 3 equal negative 6. All right, now again, you want to use a square root property, but before you do that, you got to get that part that's being squared, that expression that's being squared by itself. So we need to get rid of that plus 3. So we're going to subtract 3 from both sides, and so I get 2x plus 1 squared equal a negative 6 and a negative 3 is a negative 9. Then we're going to get rid of that squaring to get x by itself, so I got to get that expression by itself. So I'm going to take the square root of both sides. Don't forget that plus or minus. Now we just talked about the square root of a negative 9. We just talked about that. So remember that's the square root of a negative 1 square root of 9, which is I times 3 or 3I. So it goes here. The square and the square root undo each other. So you get 2x plus 1 equal plus or minus 3I. So I have complex imaginary solutions. So I'm going to just write that in compact form. Let's go ahead and subtract 1 from both sides. I'm trying to get x by itself. So I get 2x equals negative 1 plus or minus 3I. Now notice this time I don't have x yet by itself. So I'm multiplying by 2. So the opposite is to divide by 2. 2 divided by 2 is 1. 1 times x is x. You get x equal negative 1 plus or minus 3I divided by 2. And there's your answer. You leave it like that. Now you can also write them separately. You could say negative 1 plus 3I divided by 2, comma, negative 1 minus 3I divided by 2. You could write them in separate fractions if you want to. See this right here? You could say, or you could say negative 1/2 plus or minus 3I divided by 2. This and this mean the same thing. Here, you could have said negative 1/2 plus 3I divided by 2 like that. Each one divided by 2, comma, negative 1/2 minus 3I divided by 2. So all different ways of stating the solutions. All right, so that was a set of examples where you had to solve a quadratic equation. Notice though that those are all quadratic, right? Those are all quadratic, because if you FOIL this out, you're going to get a quadratic equation. But you don't want to do that because if it's of that form where you have some expression squared equal a number, you want to use the square root property. So we are using the square root property in each of those cases. Square root property. So the square root property, remember, said this: if you have b squared equal, let's say a, To get b by itself, you could take the, let me rewrite this over. You would take the square root of both sides using the square root property, plus and minus though. So the b and the b, I'm sorry, the square and the square root undo each other. So you get b equal plus and minus the square root of a. So in each of these cases, once we got the expression squared by itself, we used the square root property. We took the square root of both sides. So that is a set of examples of solving a quadratic equation using, and these are quadratic equations, by the way, keep that in mind, solving each quadratic equation using the square root property.